In the third example, they have made a bit of an error here in the question. This is a plural term. You would say that there are 2 dice. But if you have just one of them, it's not called one dice, it's called one die. So this should actually read die. So you roll a fair die. What does fair mean? Fair would mean that it's going to give you the same chance of getting any of the numbers. Now, if you're unfamiliar what a die is, it's normally at least, it's a 6-sided, I'm going to say cube actually, and on each face you're going to have a different set of numbers. And on the front side, if this is a 1, the side opposite at the back here that you can't see would have 6 dots. And the reason for that is because the opposite sides always add up to 7. So if the top here had 2, the one on the bottom here would have 5. And if this one had 4, then the one at the back there would have 3. So this is what a die normally looks like, a 6-sided die at least. How many times would you expect to obtain a 6 if you rolled it 120 times? Well, if you rolled it just once, the likelihood of getting a 6, because it's fair, is 1/6. Now if you did that 120 times, you have to just multiply this by 120 and say how many of these 120 rolls are going to land up with a 6. So if we multiply them out, we could just do 120 divided by 6, and this is 20. So you'd expect to get it 20 times. If you rolled it 120 times, you'd expect 20 of those times to have a 6 on them. But of course, experimental data won't give you the exact likelihood unless you do this 120 trillion times. You'd expect maybe a 6th of them to be a 6. So the more you do it, the more it actually turns out to be as you'd expect. What about getting an even score? So even, you could get a 2 or a 4 or a 6. Now half of the numbers are even. So if you rolled it 120 times, you'd expect half of the 120 times to give you even and half the 120 times to give you odd. So I can do 120 divided by 2, which is 60 times. I'd expect to get an even score. In a C, a score of less than 5 would be a 1, a 2, a 3, or a 4. Now, this is the numbers it could be. It would be 4/6. So 4 of the numbers out of 6 are less than 5. And in the same way that we did in part A, we would do the 4/6 and times it by the number of times that we're rolling it. So times 120. And this would be 20 times 4, which is 80 times. There is another way of doing this, which may be slightly different, slightly easier, and that's to say it's going to be the probability of getting a 5 or a 6, but then doing 1 minus that answer, because we're looking at every other option. So getting a 5 or a 6, there are 2 ways of doing it. Getting a 5 or getting a 6, there are 2. Now if we times that by 120, this is 40. And then if you roll it 120 times, you'd expect 40 of them to be what you don't want. So then 120 minus the 40 is 80. And that's another way of getting the answer. Oops, what have I done there? There we go. Sometimes, although in this case it looked a bit more complicated to do the second way of doing it, sometimes the second way is much, much easier. So I thought I'd introduce that early on. Okay, this bold line means start the exercises from 6.2.